Hello everyone, my name is Mansi Sunil Patil, currently intern at Emertxe Information Technology. I am doing this internship based on embedded system, and during this internship we have built a project based on MPLAB XIDE simulated in software PiximLab. We work on the project that is microwave oven simulation. So let's start to the presentation. This is the content of this topic. Topics learned during the internship: embedded system, introduction of microwave oven, microcontroller, CLCD, matrix keypad, interrupts, ISR, timers, conclusion, and after that we will see the project demo. Topics learned during the internship of embedded system. So first one is introduction to C language. Introduction to C programming, in that we learned about data types, that is integer, float, short, long, sign, unsigned, etc. After that, conditional loops and operators. In conditional loops and operators, we learned about if statement, if else statement, else if statement, switch case. Then also we saw about iterative statements, that is while, do while, for, etc. And in operators, we saw various types of operators, that is arithmetic operators, relational operators, logical operators, bitwise operators, and many more. Then also we saw about arrays and pointers, strings, introduction to embedded system, microcontrollers. Then we have also learned about how to use MPLAB XIDE, how to compile with the help of XCA2, and how to simulate it on PiximLab. We have attended various quizzes and sessions. So, what is embedded system? An embedded system is a specialized computing system that is built into a device to control its functions. It is designed to perform a specific task rather than general purpose computing like a laptop or smartphone. Many more embedded systems work in real time. It means they must respond quickly and accurately. There are four types of embedded system. First one is standalone embedded system, real-time embedded system. Third one is network embedded system, and last one is mobile network system. Mobile embedded system. After that, introduction of microwave oven. So what is microwave oven? A microwave oven is a common kitchen appliance used for cooking, heating, and defrosting food quickly. It works by using microwave energy, a type of invisible electromagnetic wave, to heat food from the inside. Why are microwave ovens is popular? Because it heats food in minutes. It also easy to use, and also it's safe and clean. Then about microcontrollers. A microcontroller is a small computer on a single chip that is used to control electronic devices. It has a processor, memory, and input-output ports, all in one unit. A microcontroller are designed to perform specific tasks, such as controlling a washing machine, microwave oven, or remote control car. Here in this project, we have used PIC16F877A microcontroller. It also has many features. It is widely used 8-bit microcontroller, 14-bit instruction width, 368 bytes of RAM, and it also has 256 bytes of EEPROM. It also has 33 input-output pins for interfacing with external devices. It does faster execution with simple instructions. Then about CLCD. A CLCD, that is character liquid crystal display, is a type of LCD screen used to display text, numbers, and basic symbols. It also has many features. It displays text in a fixed grid. It works with microcontrollers. It needs a controller chip to operate. The CLCD has two registers, that is command register and second one is data registers. So in command register, it used to send instructions like clearing the screen or setting the cursor. Or in data registers, it stores character data to be displayed on the screen. It also provides easy interaction in embedded systems without complex graphics. Then matrix keypad. A matrix keypad is a type of keypad arranged in rows and columns to reduce the number of connections needed to a microcontroller. Instead of having a separate wire for each button, the keys are arranged in a grid pattern. When a key is pressed, a connection is made between a specific row and column. The microcontroller activates one row at a time and checks which column gets the signal. Then interrupts. An interrupt is a signal that temporarily stops the normal execution of a program to handle an urgent task. After completing the task, the program resumes from where it's left out. It also improves systems efficiency by allowing immediate responses to critical events. It used in time-sensitive applications like motor control and individual automation. There are two types of interrupts, that is hardware interrupts and second one is software interrupts. Hardware interrupt triggered by external devices and software interrupt is triggered by program itself. Then ISR. ISR, that is interrupt service routine, is a special function that runs automatically when an interrupt occurs. It handles the interrupt task and then allows the program to continue from where it stopped. The current task is temporarily halted to handle the interrupt. Timers. A timer is a special counter inside a microcontroller that keeps track of time. It helps in measuring time delays, generating signals, or controlling tasks at precise intervals. A timer counts up from 0 to a set value. When it reaches the limit, it can trigger an interrupt or reset and start again. It runs independently of the main program, making it useful for real-time operations. The timers increments or decrements its count based on the clock pulses. The timers receive clock pulse from the system clock. When the timer reaches its maximum value, it generates an interrupt or reset, as I said. Then let's move towards the conclusion part. In conclusion, a microwave oven is a fast, easy, and efficient way to cook and heat food. It works by using microwave radiations to heat food quickly and evenly. Due to its convenience, energy efficiency, and safety, it has become an essential appliance in homes and workplaces. So let's move towards the project demo. So here you can see we have included many header files here in main.c file. In this microwave oven project, we have implemented the overall functionality of the system, integrating different modules such as the LCD display, matrix keypad, timers, control logic, etc. Here the microcontroller ports and peripherals are initialized, including the LCD, keypad, and timer setting. When the microwave oven is turned on, powering on message will be appears on the LCD. Here in microoven.c you can see that. The user can select different cooking modes. There are 4 types of cooking modes. You can select anyone from this. With the help of keypad, we can set the cooking time, temperatures as per our requirements. Based on the selected mode, the system starts the heating process by activating necessary components such as fan. The countdown timers continuously updates the remaining cooking time on the displays, and the system stops when the timer reaches to 0. Also, the user can pause or stop the microwave oven at any time using the keypad. So, we will see the demo. So, let's see. This built successfully. After that, we will load this file to see the process of microwave oven. Here you can see the powering on message which is displaying on the LCD. After that, you can see there are 4 types of mode. In that, you can select anyone. So, when I select microwave oven mode, here you can set times. So, I set 23 seconds. After that, enter. You can see the fan will turn on. And we can also pause this process. After pausing, we can also start this. Then also stop. Here we can see after stopping, we reach to this point. Then also we can select grill mode. In grill mode, here also we can select time, 24 seconds. Here you can also clear that by using star keypad. After entering, here also fan is on. We can pause here. Also we can start here. And so we can stop here. Then third one is convention mode. Here you can set temperatures. When we set temperature greater than 100, you can see time remaining is 60 seconds. So that's it. You can see the execution of this project. So thank you so much.